Hello and welcome. I am Olive, your reader for today's topic. We may have found a super-Earth planet with an atmosphere. So let's begin. Scientists using the James Webb Space Telescope, JWST, may have uncovered one of the holy grails of astronomy and astrophysics: the discovery of a rocky exoplanet with an exotic, water-rich atmosphere. Then again, it might all be an illusion. JWST was designed, in part, to hunt for such planets, and GJ 486b would be the first identified. The problem is, the planet closely hugs its parent star, a red dwarf, and lies well outside the habitable zone. Temperatures on the planet, which is larger than Earth, reach a scorching 800 degrees Fahrenheit, too hot to support life as we know it. It's in no way habitable, said Sarah Moran, a planetary scientist at the University of Arizona in Tucson. How JWST uncovered a possible atmosphere. JWST detected the planet's atmosphere, or at least evidence of one, by zeroing in on the planet as it passed in front of the star. As starlight filtered through the shroud, the telescope recorded the changes to the near-infrared part of the spectrum. After crunching the data, the scientists concluded that the planet lacked the most common planetary gases: carbon dioxide, methane and hydrogen. What it did have, perplexingly, was plenty of water vapor. This was strange because a super-Earth planet in tight orbit around a star, a major source of vapor-destroying radiation, was no place for the stuff. The team concluded that if the planet did have a watery atmosphere, it would have to be continuously replenished, perhaps by steam-belching volcanoes. Those could release water from inside the planet. There is no comparable atmosphere in our own solar system, said Kevin Stevenson of the Johns Hopkins University Applied Physics Laboratory, in a press release. We could be exploring a brave new world that would speak to the diversity of exoplanet atmospheres out there. A potential exo-disappointment. The strange new atmosphere could also be something much less exciting. Despite their great temperatures, dwarf stars can and do harbor water molecules in their own atmospheres, their photospheres. The researchers had to wonder if that's what JWST had detected, rather than some exotic atmosphere around an exoplanet. Such water is most likely found around star spots, cooler, darker areas on the surface of a star, though the telescope's data showed no evidence that the planet had crossed near one of those. But that doesn't mean that there aren't spots elsewhere on the star, said Ryan McDonald, an astrophysicist at the University of Michigan, in a press release. And that's exactly the physical scenario that would impart these signals into the data and could wind up looking like a planetary atmosphere. The next step. Researchers plan to point the JWST's mid-infrared instrument at the planet's scorching day side to probe the possible atmosphere from a different angle. They're looking for how the heat spreads across the planet's surface and whether it sits directly under the star. Or they may find that the warmth shifts as it circulates in the atmosphere. That would be the evidence they're looking for, according to the project's proposal. By analyzing the atmosphere, the detection of an atmosphere surrounding on a super-Earth planet is a significant breakthrough. The presence of an atmosphere is crucial for various reasons, as it not only shields the planet's surface from harmful cosmic radiation but also regulates temperature and facilitates the existence of liquid water. By unveiling the super-Earth planet, researchers, Space-based Observatory by James Webb Space Telescope, has detected an exoplanet that possesses the characteristics of a super-Earth planet. Situated within a habitable zone around its host star, this planet offers a tantalizing glimpse into the potential for life-supporting conditions beyond Earth. Consequently, the identification of an atmosphere on this super-Earth brings us one step closer to understanding the habitability of distant exoplanets. What is the potential habitability of exoplanets? Currently, only an estimated 1.5% of exoplanets discovered have been catalogued as potentially habitable worlds. According to computer simulations, this exoplanet could have a moderate Earth-like atmosphere and moderate temperatures. Through observational techniques, the discovery of an atmosphere on a super-Earth relied on several innovative observational techniques. One of the key methods employed was transmission spectroscopy, which involves analyzing the starlight that passes through the exoplanet's atmosphere during a planetary transit. By carefully examining the spectral fingerprints imprinted on the transmitted light, scientists can infer the composition and characteristics of the atmosphere. The spectrographs on board the James Webb Space Telescope, Webb, provide scientists with the data needed to analyze the materials that make up stars, nebulae, galaxies and the atmospheres of planets. Composition and potential for life. While the exact composition of SuperEarth planet atmosphere is yet to be determined definitively, initial observations suggest the presence of key molecules such as water vapor, methane, and carbon dioxide. These molecules are considered vital for the existence of life as we know it. However, it is important to note that the presence of these molecules does not guarantee the presence of life, but rather signifies the potential for habitability and further exploration. Future prospects. The detection of an atmosphere on GJ 486b represents just the tip of the iceberg in exoplanetary research. With further advancements in technology, such as the upcoming next-generation telescopes and space missions, scientists anticipate uncovering more detailed information about the atmospheric composition, climate, and potential biosignatures of exoplanets. These future endeavors will significantly contribute to our understanding of the prevalence and diversity of life in the universe. Researchers have taken a significant step forward in unraveling the mysteries of distant worlds. This breakthrough fuels our curiosity and determination to uncover the secrets of the universe. As research in this field progresses, we inch closer to answering the age-old question: are we alone in the cosmos? Or, in a statement, opens in a new tab. But we must be careful and make sure that the star is not the culprit, said Kevin Stevenson, the principal investigator of the study from the Johns Hopkins University Applied Physics Laboratory. I hope you liked the article. Here is some glossary for you to know the meanings of difficult words. Grails. Someone is trying very hard to obtain or achieve it. Red dwarf. A red dwarf is the smallest and coolest kind of star on the main sequence. Red dwarfs are by far the most common type of star in the Milky Way. Harbor. A harbor is a body of water. The harbor is deep enough to keep ships from touching bottom and should give ships and boats enough room to turn and pass each other. Photospheres. Visible surface of the sun, from which is emitted most of the sun's light that reaches Earth directly. Probe. A thorough investigation into a crime or other matter. Cosmic radiation. Consists of high-energy charged particles, X-rays and gamma rays produced in space. Habitable zone. Is the distance from a star at which liquid water could exist on orbiting planets' surfaces. Habitable zones are also known as Goldilocks zones, where conditions might be just right, neither too hot nor too cold, for life. Distant exoplanets. The most distant potentially habitable planet confirmed is Kepler 1606b, at 2,870 light-years distant, although the unconfirmed planet KOI 5889.01 is over 5,000 light-years distant. Transmission spectroscopy. The power to probe the physical conditions in the atmospheres of exoplanets, as it allows for the detection of the various absorption features that are imprinted on the stellar light that passes through their atmospheres. Scorching. Very hot. Perplexingly. To confuse or trouble with uncertainty or doubt. Steam-belching volcanoes. Volcanic gas. Burping. From a fiery peak signals magma moving down below, a warning sign of a possible eruption. Unveiling. The presentation or announcement of something in public for the first time. Tantalizing. Possessing a quality that arouses or stimulates desire or interest. Spectrograph. An instrument that separates incoming light by its wavelength or frequency and records the resulting spectrum in some kind of multi-channel detector, like a photographic plate. Many astronomical observations use telescopes as, essentially, spectrographs. Biosignatures. Complex organic molecules or structures whose formation is virtually unachievable in the absence of life. Prevalence. The fact or condition of being prevalent, commonness. The prevalence of obesity in adults. Unravel. Investigate and solve or explain something complicated or puzzling. They were attempting to unravel the cause of death. Thanks for watching. Please subscribe, share and comments. Stay connected for more updates.